Okay, the last chapter this year. Yay! All right, so for this last chapter, it is all about solving systems of equations. There are 3 different ways you can solve a system of equations. You can do it by graphing, or 2 other ways we'll find out later on about. Today, we're just going to cover the graphing part of it. And when you do a system of equations and you solve it, by graphing, you obviously have to have a graph, but you only want one graph for every problem. Every time you see a system of equations, this is what we're talking about. It's where you have more than one equation in your problem. They want to know what x and y will make both of those statements true. Not just one of them, but both of them. It has to work for both. So if you're going to solve a system of equations by graphing, then you have to solve each individual equation for y first. Then you'll want to graph each of the equation on the same coordinate plane, and then the point where they cross, that's what your answer is. So let's look at this one. If I were going to solve the first one, I'm going to do it in orange so it'll show up. X minus y equals 2. I need to solve it for y. So I'm going to subtract x from both sides. That gives me negative y equals negative x plus 2. And then I have to divide everything by negative 1 to get rid of my negative. So I have y equals a positive x minus 2. When I go to graph that, since it's in slope-intercept form, that's why you solve it for y, I have to start at my negative 2, so that's down here, and I put my dot. And then I follow my slope, which in this case is 1 over 1. So I go up 1 and over 1. Up 1 and over 1. I'm going to do a few of them so that I can get a pretty accurate picture. When you're doing it on graph paper, you don't need to do quite as many because you have all those lines and grids there. Even if you did it on your Post-it notes, you would still have all the lines and grids there, so you don't have to do quite as many. This line looks like that. So now I need to go in and do the other line. I'm going to do it in a different color so that you can see what I'm doing. When you're doing it on your paper, you can do it the same color, that's fine. So it's x plus y equals 8. So I need to get the y by itself, so I'm going to subtract x from both sides. So y equals negative x plus 8, which is the same thing as negative 1 over 1x plus 8. So I have to start at 8. 8's a ways up for me. Hold on. 1, 2, 3, 4, 5, 6, 7-ish, 8-ish. And then from there, I go down 1 and over 1. 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 Oh, it's a little further down than that. So that line looks like that. And your answer is where those 2 lines cross. Those 2 lines cross right there, which I can count to that point. 1, 2, 3, 4, 5, and then up 3. That's the point 5, 3. That makes 5, 3 my answer. It's where they cross. When you're doing these problems, you need to make sure you either do them on graph paper or on those Post-it notes of yours, because you have to have a graph and you want to make sure it's as accurate as possible so that you can tell where they're going to cross, because sometimes you have to count over and it's not always at a perfect little crossing point. This one happened to be. I picked it that way so that there wouldn't be an issue with it. It's not hard to do. It's just go ahead and graphing them and figuring out where they cross. Simple as that. So I'm going to go ahead and erase some of this so that we can look at another one. Well, how about some facts first? Systems of equations that have at least one solution, like this one did, it had 5, 3, are said to be consistent. So we would describe this particular system of equations as being consistent because it has a solution. If it has no solutions at all, which means it must not cross, because that's the only way you're not going to have any solutions, then it's said to be inconsistent. So when it has an answer, it's consistent. And when it doesn't have an answer, they call it inconsistent. Let's look at another example. Two x minus y is equal to 4, and 4x plus 8 is equal to 2y. So you were supposed to solve both of those for y so that we can graph them. I'll give you a few seconds to do that while I erase. The first one is 2x minus y equals 4. I got to get the y by itself, so I'm going to subtract 2x from both sides. Negative y equals negative 2x plus 4. Divide everything by negative 1. Y equals positive 2x minus 4. So this time we start at negative 4. And I go up 2 and over 1. So it looks something like that. You'll have a straight edge, so yours will be straighter than mine. You know, ruler. You got that. For the other one, I'm going to use a different color again. We have 4x plus 8 is equal to 2y. So I have to get the y by itself. I'm going to flip it over so I already have my 2y on this side and put the 4x plus 8 on the other side. I didn't move anything, I just flipped it over like a pancake. Then I'm going to divide everything by 2 because I like having the y on this side. And get y equals 2x plus 4. So that means I have to start at positive 4. 2, 3, 4. Put my dot. And then from there I go up 2 and over 1. Up 2 and over 1. Up 2 and over 1. Looks a little off. Even if I went down 2 and back 1, because I'm getting short. That's about what it looks like. My line dropped down. And even with my bad lines and no straight edge, you can tell that these are going to be parallel, so they're never going to cross. And we know that before we ever even graphed them, because I know that you saw that this slope and this slope were the same, and I know that you remember from chapter 9 that lines that have the same slope are always parallel. It's when the lines are parallel that they're never going to cross. And if they never cross, then they can't have a solution. There is no answer, which means your answer up here is no solution. There is no place where both of those are true. And since your answer is no solution, that makes this particular problem inconsistent. Your answer is no solution, but you can describe the system of equations as inconsistent. But wait, there's more. Here, I'm going to put it in black. I was doing all your notes in black. So, System of equations that are the exact same line, like if both of those were the same line, then they would be called dependent, and systems of equations that have different lines are independent. This is an independent system of equations. This is also inconsistent because you get to choose from up here and down here every single time. So this one happens to be inconsistent because it was no solution, but it is independent because they are different lines. The first one we did was consistent because there was a solution, but it was also independent because there were two different lines. They weren't the same line. Let's do another one. That was example 2, by the way. I never changed my 2 there. Hope you caught that. So this one's going to be example 3. Two x minus y equals 4, and then 2x minus 4 equals y. Give you a second to go ahead and solve those. It's crooked. Okay, let's do the 2x minus y one first. Got to get the y by itself, so I'm going to subtract 2x from both sides. So negative y equals negative 2x plus 4. Divide everything by negative 1. Y equals 2 over 1x minus 4. 1, 2, 3, 4. Up 2 over 1. 2 over 1. 2 over 1. Okay. The other one I'll do in pink. It was 2x minus 4 equals y. Got to get the y by itself, but wait, the y is by itself. So if I go flip it like a pancake so I can see it the way I want to see it, I get 2x minus 4. That's 2x minus 4. The same line. Didn't look the same up there, but it is the same down here. So if I were to graph it, it would be directly on top of it. So since they are the same line, that means their answer is not all real numbers. It is infinitely many. Many solutions. Now, I'm okay with this. Chances are in the back of the book they don't have this. Chances are in the back of the book they have something like whatever this line is, because that is what the answer is, all the things that fit into that line. All x's such that this is true kind of thing. But I'm okay with this because this tells me what I wanted to know, how many there are. If we have infinitely many solutions, that means it's more than one. You got to catch on to that. Since there's more than one solution, that means that it is consistent because there's more than one. That's why this one had to say at least one solution, because you can't have more than one. So since there's more than one, that means that it is consistent. However, since they are the same line, it is dependent, not independent. So these words you have to know in addition to how to find your points over there. You got to be able to do both. Time for classwork and homework. I've shown you all the stuff you need to know. You might want to go back and look at it again if you're going to leave some time in between now and when you do your classwork or when you do your homework. That's entirely up to you. It is on page, don't write it right here. I didn't realize I would open it with black. Up here. Page 446. Classwork. 1, 5, 9, 11, 15, and 19. Homework. 3, 7, 13, and 17. Less homework, more classwork. That's the way it works in this section. The next section you're going to think is completely different because there is no graphing. There's no graphing because graphing is only one way we can do these. So I will see you, well, you'll see me tomorrow.